First runs 4 different levels of competitions, the first one being Junior FLL for younger elementary school students, First Lego League for older elementary school students and middle schoolers, and First Tech Challenge and First Robotics Challenge for high school students. We participate in First Tech Challenge.
The first competition that Antipodes participated in was FLL, which is a competition where you have one autonomously programmed robot, which means that it is pre-programmed and does everything on the field without any remote control on a 4x8 field, in which you complete multiple challenges in 2 minutes and 30 seconds.
Can I ask a question? Does it have a computer and you program it into that? Or?
Yes.
Yeah, there's a little ST brick inside, and that's where all the programming goes ahead of time, and then you put it on the field.
Thank you.
Alright. So this is a video of a run in our FLL year. It's picking up loops to score points when it returns back to base. And this is all autonomous, so all this is pre-programmed.
How long before the run are you given?
2 minutes and 30 seconds.
Before, how much advance notice are you given?
About
what has to do?
a month and a half, 2 months.
Before the first competition.
Yeah, that's when we find out what the challenge is, and that's when we can begin building the robot and programming it. So during our FLL year, we competed in various competitions, and over 300 teams competed, and we made it to the Northern California Championships and placed second, and we're invited to go to the World Championships held in Istanbul, Turkey.
Istanbul?
Yes.
Yeah.
Wow.
So while we were there, we met a lot of great teams, and we had a lot of fun, and it really helped shape our robotics experience and the rest of our lives.
So as part of the FLL competition, we had to complete a research project based on the theme Smart Moves. So what we decided to do was do a research project on maglev, a magnetic levitating train. In doing so, we built a small model of a working maglev, which we had to go through some iterations to make it finally work, but you can see in the corner down here of the complex circuitry, and that is our final working model. We presented this maglev at Make a Fair, a do-it-yourself festival in 2010, and we also presented it to Google engineers along with our experiences from FLL in the form of Google Tech Talk. And after touring the campus, Google seems like a pretty cool place to work.
So we also got the chance to mentor other teams. This team was the team we mentored last year, and we're hoping to mentor more teams. And during this time, they were actually mentoring on that computer. They were doing a Skype call to a team that I'm in Australia. So I am here on a robotics exchange in the Antipodes team, and we all worked together on this set of robots, which was for an autonomous sort of puppet show competition. And we as a team worked on this for a while, and we won a national competition in Australia, which the team later represented in Istanbul and won the World Championships with it. During this time in Tasmania, Australia, we also participated in the FLL Tasmanian State Championships, which we also won.
So FTC is 4 teams competing on a 12x12 field. There are 2 alliances. So within a tournament, there are many different matches, and each time you get a different alliance partner and different opponents.
So one of the main differences between the FLL competition and the FTC competition is the parts used to build the robots. As you can see on the left here are the pieces used to build an FLL robot. The brick we were talking about earlier is up in the middle of all the sensors and the motors. And all of the pieces are plastic, while in FTC, they're it's all metal pieces, and there's DC motors and servos and a lot more wires, so a lot more electrical engineering is involved.
The programming is also different. The main programming language used in FLL is a image-based programming, as you can see on the top. And in FTC, you mostly use a text-based programming based off of C, which is C below.
And also in FTC, since we're working with metals and bigger pieces of metal and not just little plastic Lego pieces, we have to cut and drill and work with a lot of machinery to get the pieces that we want and customize our robot so that it is the robot that we have to compete in competitions.
We also did a lot of CAD modeling, and as you can see, we built up our robots through all of the pieces on a computer.
So right now it just looks kind of like a big mess just sitting in front of you, but that's it, getting built bit by bit, built up.
And this is the robot that we competed with at our first tournament. And later, we added on an arm that enabled us to pick up batons off the ground.
As you can see, there are a lot of different components in our robot.
So there's an 18-inch size limit cube, which when we extend out, we exceed, but we can close down to fit within it. So at the beginning of the match, we start out closed up like this.
Can I just ask a question?
Yeah.
All of these pieces, obviously you designed and constructed all. It's not meant from any kit or anything, so you fabricate the
There
pieces?
is a kit that we use called Tetrix. It gives you basic pieces, but you're allowed to customize any of them, and you're also allowed to put in other pieces. Like we used PVC and we added aluminum sheets. So there is a basic kit that you can start off with, but it leaves room for you to design really whatever you want.
Yeah, they have some specifications about what kind of metals you can use, so you have to use the pieces from the Tetrix kit for the most part. Like most of the bars that you see and like most of the screws and everything come from the Tetrix kit.
Everyone's using the same kind of stuff?
Yeah, but everyone cuts it differently, everyone puts it together differently. Each will have its own unique aspect. And so every year, since there are different robots, there's also different challenges every year for FTC. And this year, there were 2 different sides of the field, and there were various ways to get from side to side. And there were a couple components. There was the ways to score were by scoring batons into these rolling goals. There are 4 rolling goals and 2 stationary goals. And you can dispense batons from each baton dispenser, and different alliances have the different baton dispensers. And there's at the beginning of every match, there is a 40-second autonomous period where it's just pre-programmed, and each baton that is dispensed, not necessarily scored, but just dispensed, you get points for.
So this is a video of one of our autonomous periods.
We are in the upper right.
Yeah, so we are...
You start out with 5 batons for your team that you can score. So we score it.
Yeah, the preloaded baton.
We just scored it right there. And we're turning over to go over the mountain. And underneath the baton dispenser, there is an infrared beacon, which our robot is seeking, so it can line up and dispense the baton.
And you can see the batons getting lower as we dispense them. And you also could have noticed that a lot of the other robots were sort of scattered, and that's because during autonomous period, you don't know what other robots might be doing on the field, and so anything could really happen during that period.
So after this 40-second autonomous period, there's a 2-minute tele-op period where teams are allowed to drive their robot using controllers. The main way to score during this period is at the end, where you try to balance as many objects as possible on your bridge. The keyword balance. It can't just park there, it has to balance. And this requires a lot of cooperation with your alliance partners. So,
and also the more components that you get onto the bridge, the more points you get. So if you have 2 robots on the bridge, then you get more points. If you have 2 robots and a rolling goal, then you get more points. You try to get as much on there as you can.
Okay. Okay. Well, in this video, you would have seen our robot grab a rolling goal and balance with our alliance partner on the bridge.
This year, instead of going to California competitions, we went to Colorado competition, a Colorado competition, because they were in Australia during the California competitions. And so at the Colorado Championship, we ended up being the captain of the winning alliance, and we got our ticket to World.
So the World Championships was held in St. Louis this year at the dome that the St. Louis Rams football team plays at, to accommodate about 20,000 students, all competing in the 4 different levels of first. And it was a 4-day-long competition which we met lots of different teams and had a really amazing time.
And so this is a video of one of our runs at St. Louis, and in between Colorado and World, we added the arm, which was initially used for picking up batons, but we also found out that it could be used for flipping us back over when we toppled onto our backs.
Yeah,
So we started out upside down, but
it was very thrilling for us because we had no idea that it was even capable of it.
yeah, we didn't know our arm had enough power, but it was very exciting for us.
Sorry. Okay, so. Yeah. All right.
Also,
There you
recently, will.i.am of the Black Eyed Peas has become kind of a spokesperson for First Survive, and he did a television series on it. So while we were there, the Black Eyed Peas gave a free concert to all of the competitors of the competition, Vote of the Night.
And it was a big surprise for all of us.
Yes,
We were beyond
it was very
excited.
exciting.
And so we guessed, because they were testing out the light.
Yeah. And so, like, robotics keeps us all really busy. So some of the events coming up in September or end October are a robotics presentation at the Google headquarters, a robotics presentation at Abbott Vascular Technology Expo, a power tool presentation to fellow teams, a planetary rover simulator experience at Shark Park Library, Math demonstration at a mini maker fair, teach robotics classes, mentor Palo Alto Girls FLL team, and design and build this year's robots.
The new challenge comes out on Saturday, so we're really excited to find out. And so this is for the planetary rover simulator experience. We added a webcam so that younger kids can drive around our robot and look from a different location where they're going, like you would if you were driving a rover on Mars. And so if you want to learn more about our team, go to www.theonerobot.com, where we have all our information about our and what's going on with us.